Hi everyone. So to start off with this new unit, we are going to be revisiting the fundamental theorem of calculus. Remember that we are looking at definite integrals, so we have a lower limit a and an upper limit b. For this section, we're just going to be evaluating integrals using all the methods that we have learned this past unit. So U sub, by parts, and trig identities. So for the first example, we have the integral of sine squared x times cosine cubed x from 0 to pi halves. Notice that we have two trig functions. They're also at higher degrees. So most likely I'm going to be using trig identities. So what I'm going to do is rewrite this integral so it's in terms that we can use for the trig identities. Boop. Squared times cosine x dx 0 to pi halves. Notice that we have sine squared x and cosine squared x. So now we can use those trig identities. Because I have this cosine x dx, I am going to rewrite the cosine squared x. So what I'm going to have is the integral of sine squared x times 1 minus sine squared x times cosine x dx from 0 to pi halves. I'm going to set u to equal sine x. So that means my du is going to equal cosine x dx. We could have rewritten everything, and so where u is cosine, but that would give us a negative du. So that's why I wanted to use u equals sine x, so we have a positive du. So now I'm going to rewrite this integral right here. So I'm going to have the integral of u squared times 1 minus u squared du from 0 to pi halves. This is going to equal the integral of u squared minus u to the fourth du from 0 to pi halves. Now what I'm going to get is u cubed 1/3 minus u to the fifth times 1/5 from 0 to pi halves. This is going to equal 1/3. Now replace the u with the sine x, so sine cubed x minus 1/5 sine x to the fifth power from 0 to pi halves. All right, so what I'm going to do is evaluate the upper limit first. So I'm going to do f of pi halves minus f of 0. So that's going to equal 1/3 sine cubed of pi half minus 1/5 sine pi halves to the 5th power. Then I'm going to subtract 1/3 sine cubed of 0 minus 1/5 sine of 0 to the 5th. Notice that sine 0 is 0. So sine 0 at any power is going to give you 0. So now we can just focus on this first piece right here with the pi halves. So on the side, I'm just going to do sine pi half. Sine pi half equals 1. So right here I have 1/3 times sine pi half, which is 1 cubed, minus 1/5 times 1 to the 5th power. I get 1/3 minus 1/5. I'm going to find common denominators, so 3 times 5 is 15. 5. 3 times 5 is 3/15, so 5/15 minus 3/15 equals 2/15. And that is my final answer for number 1. All right, let's go on to number 2. We have the integral of ax divided by x squared minus 4 from 3 to 6. Notice that we have an x squared. If we take a derivative, we get 2x. So we have an x squared in the denominator and an x in the numerator. So I'm going to use u sub. U is going to equal x squared minus 4. Du is going to equal 2x dx. But we need an 8x, so I'm going to multiply by 4 to both sides. So 4 du equals 8x dx. So now I have the integral of 4 du divided by u from 3 to 6. I'm just going to rewrite this so I have 4 in the front, 1 over u du from 3 to 6. The integral of 1 over u is going to be the natural log of the absolute value of u times 4 from 3 to 6. This is going to equal 4 times the natural log. Replace the u with x squared minus 4 from 3 to 6. So I'm evaluating the upper limit first, so f of 6, then subtract the f of the lower limit, so f of 3. We're going to get 4 times the natural log of the absolute value of, 6 squared is 36, minus 4 is 32, minus 4 times the natural log, absolute value of 3 squared, which is 9, minus 4 is 5. We can use the natural log properties. So this is going to equal 4 times the natural log of 32 divided by 5. That's my final answer in natural log form. Or if you want to do the decimal out, you get approximately 7.0 425. And that is my final answer to number 2.